In this video, I'm going to give you a tour of PowerShell Universal 1.2. PowerShell Universal is a platform for building web-based IT tools. It includes Universal API, Universal Automation, and Universal Dashboard. For this video, I downloaded the MSI from our website and I installed it as a service. So you can just go to our downloads page and download the Windows MSI if you want to run it from here. After you install the MSI, you're going to actually have a PowerShell Universal service running. It's also going to open your default web browser to the PowerShell Universal login page, and you'll see that it opens on port 5000 by default. To log into PowerShell Universal the first time, you can just type admin and any password. After you log in, it's going to take you to the admin console for PowerShell Universal. On the left-hand side, you'll see the various products that are part of this platform. We have APIs, automation, dashboard, and then some settings for the platform itself. So API allows you to create APIs that are based on PowerShell scripts, and then any HTTP client can invoke those scripts over the web. Automation allows you to create scripts and schedule those scripts, run those scripts, audit the scripts, and validate that users have access to the scripts. And then finally, we have dashboards, which is Universal Dashboard, running inside PowerShell Universal. I'm going to step through each one of these features and show you some of the basics of each one of them. So first, we're going to get started with APIs. So as I said earlier, APIs allow you to create API endpoints based on PowerShell script. So if I want to add a new API, what I can do is specify a URL and then a method for this particular API. First, I'm going to just do a user get method and click OK. So in this case, it's going to create an API, and you can see the URL up here is my user URL. I have the method get, and I have an empty script. So for this example, I'm just going to return a user from my API. As you can see, I have a hash table that I'm just creating and then returning it via PowerShell. Universal APIs actually will serialize PowerShell objects or PS objects or hash tables to JSON automatically. You can also return strings if you don't want to have it that serialize it. You can use convert to JSON to do so if you want some control over the data that's returned. So if I save this and I actually go over to my command prompt, and then I'm going to use invoke REST method to call my API. By default, like I said, we're listening on port 5000, and if we call the user URL, which is what I configured for my API, you'll see that I returned an object that contains the properties of that hash table. The API itself actually returned this as JSON, and then invoke REST method automatically converts it to a PS object. One thing you'll notice is that the department is empty, and I was expecting a department variable to be specified for this particular API. What I can do is actually integrate directly with query string parameters, and if I specify the department here, you'll see that that is actually passed to my script, and that variable is expanded and then returned as a hash table property. So you can pass in any number of query string parameters, and they'll show up inside your API endpoints as variables that you can just use in your scripts. Next, let's create another API endpoint that allows us to pass in a variable in the URL. So I'm going to do another user URL, but this time I'm going to actually specify a section of the URL that is actually a route variable. So I want an ID route where I can specify the ID of the user they want to retrieve. So again, I'm just going to do a get method and then click OK. So now I have an empty script, and instead of this script, I am going to specify ID. So each one of the sections of the URL that contains a colon like this will be passed in as a variable. So in this case, I just want to access the ID variable that will be passed in via the route. So if I save that and I go back to my command prompt here, what I can do is then just specify the additional route parameter, and in this case I'm just going to specify 10 for the ID, and if I click enter, you'll see that it executed my PowerShell script and just returned the ID back to the user. So this could be used to do lookups of particular resources, or to invoke or update different resources via the URL. Additionally, we have access to things such as the body of the the account or the request. So what we're going to do is add a new endpoint, and we are going to do a post method in this case. So I just want to do user again, but in this example, I'm actually going to change it from the get method to the post method. I'm going to require authentication, and I want only administrators to be able to call this particular endpoint. So I'm going to click OK here. And now you can see that we have an API where the user URL is now a post. It requires authentication, and it requires that you have the role administrator. So what I'm going to do is just update this particular endpoint to return the body that is passed to this request. So the body is a special variable that you will have access to, and if there is content provided by the HTTP client, it will return that to the script here, and then you can process that however you want. In this case, we only support, or in this version, we only support strings, so this could be XML or JSON. In the next version, we're going to add support for binary and file-based bodies so that you can process files in your REST APIs as well. So if I save that, now I go back to my URL. I can't just call this directly because it requires authentication. So I'll show you how to provide an app token to properly authenticate with this API. So first of all, I want to change the method to post. I'm just going to specify a body of just hello, and I'm going to have that echoed back to me. And now I need to actually get a hold of an app token that I can use to integrate with this API. So if I go into PowerShell Universal and select Settings, Security, App Tokens, you'll see that I have an app token created for my particular user account. I can copy that app token to the clipboard, and now I can use that with the API itself. So app tokens can be revoked. You can specify different access for the identity of the user that you want accessing the API, that kind of thing. But in this case, I just have my admin account that has full privileges, and I need to specify the authorization header to access this API. So I am going to specify the bare authorization here, and then I'm going to include my app token. So now you can see that when I invoke the API, I successfully returned hello. I specified hello as the body of this method request, and in this case I'm just echoing it back to the user. So you could do whatever you want in this particular scenario. For example, you could process some data, you could create a new user in Active Directory, so on and so forth. So that is an example of the Universal API integration in PowerShell Universal. One thing to note about all configuration data that's part of PowerShell Universal is that it's actually stored as PowerShell scripts. So the API that we just looked at is actually stored as a PowerShell script inside a repository folder. By default, the repository folder is inside Program Data Universal Automation /repository /.universal. Inside that folder, you'll find a bunch of different files for various configuration options inside Universal. The endpoints that we just configured are available in the endpoints.ps1 file. And as you can see here are the URLs that I defined, and then the actual scripts that are executed when these URLs are invoked. So each one of the configuration settings inside Universal is actually stored inside these files so that you can have reproducible instances of Universal. You can also source control these files, and Universal will integrate with Git automatically to synchronize your changes so that you can work with pull requests and your DevOps best practices, and Universal will reconfigure itself based on the changes to these PS1 files. All the admin console is doing is outputting these PS1 files, and then if they are changed, it's watching to see if it needs to update itself again to reflect the changes that are made in the PS1s. Now let's take a look at Universal Automation. Universal Automation allows you to add your scripts, schedule them, view the output of the scripts, and then audit who is actually executing the scripts. So we're going to go through some of the basics of Universal Automation, and then just get into some demos. So first of all, to add a new script to Universal Automation, what we're going to want to do is actually click the New Script button in the top right corner of the automation page. What you can do is then enter a name. In this case, we're going to do output because this script is going to demonstrate some of the output capabilities of Universal Automation. You can then specify things such as a description, if you want to disable people from invoking this script manually, the manual execution time, so that would be so that you can track whether or how long this script would take to do by hand, and then validate how much time you're saving. We keep by default a max job history of 100 scripts or executions of a script, so that as to keep your database nice and snappy. The error action by default is set to silently continue. That means that if you have errors in your script, your job will not report as failed. But if you change that to stop, for example, it will report your job as failed if there are errors encountered. And finally, we can customize the PowerShell version that we want to run this script in. So we're going to click this, and when we actually create this script, just like with APIs, it's gone ahead and it's actually created a new script, this output script, in our repository folder, as well as in the scripts.ps1, it's created a registration for that script. This includes the path of the script as well as the name of the script that you'll see in the UI. Here you could alternatively have absolute paths, but this path without any root is actually defaults to the repository root folder. So now that we have a script, let's go ahead and edit it. You can just click the edit button, and I'm going to put get process in here. Click save, and we can go ahead and run our script. When you click run, you have some options to select the PowerShell version again, or and alternatively go to the script if you want. So when I click that, it's going to take us over to the jobs page. This has information about when it was started or created, when it was actually started, when it ended, the PowerShell version it was executed in, the user account it was run under, and then as you can see in the middle here, all the output from the actual script that's running. So our get process output looks very similar to what you'll see in a PowerShell console. So as we scroll down, you can see it's just outputting all the different processes that I have running on my system. And as that finishes up, what you're going to see is we are going to see all the output, which is stored automatically for you if they're scheduled or not, or if they're run interactively like we did just here. In addition to storing the string output that you're seeing here, we also store pipeline output. So after this script finishes up, we're going to go over to the pipeline tab, and what you'll see here is that we actually have the objects that were returned from getProcess. Because getProcess doesn't just return strings, it actually returns system diagnostic process objects. You can see that we actually have access to all that information inside the pipeline output tab. So this includes all the properties of all the objects that were returned from a particular script. So in addition to being able to just look at all these properties like we're doing here, you can also retrieve these pipeline output objects from other jobs using the Universal PowerShell module. And that means you can have jobs that produce particular output, and then we store that for you, and then you can actually access that output again in a different script to further process that data. So this is actually stored as CLI XML inside the database, so they're not actually live objects, but they provide you with all the information about the objects that were returned from a particular job. In addition to the job output here, you'll also have errors if there were any listed here, and additionally, if there are parameters or input values, you'll have more tabs show up. So what we're going to do is now we're going to look at how to take input in your scripts. So I'm going to create another script. We're going to call this one input, and we're going to go to the script. And the way that Universal Automation works is that it actually looks at the param block to generate an input form for you automatically. So this is kind of similar to what Universal Dashboard is capable of, except that it runs in the Universal Automation job engine to provide all this output and that kind of thing, unlike Universal Dashboard, which is primarily focused on creating UI controls. So what we're going to click here is click Edit, and then I'm going to put the param block in here. And at the top you can see that we have several parameters that we've included in our param block. The first one is username. It's a string, and using the parameter attribute, we're specifying that this particular parameter is mandatory. The second parameter is temporary, and we're going to make that a bool. and that kind of indicates to Universal Automation what kind of control we'd like to show up on the UI. Finally, we have a start day parameter that is a system.dayofweek, which is a .NET enumeration, which has a set of values that we are going to show in a drop-down list. So now if we save this and we click Run, what you'll see is we have a username text box at the top here that is required. We have a temporary boolean, which is a switch that we can turn on and off. And then we have a start of day dropdown that allows us to select one of the values of that system.dayofweek enumeration. So Universal Automation supports types such as strings, bools, enumerations, validate set arguments or attributes, as well as date times and PS credentials. So if I click Run now, it's going to run that script, and it's going to pass those parameter values directly into my script. So now you can see that all I did within my script was actually just output what was passed in, and we have access to the test, true, and Monday values that were provided. And as you can see, in this case, we actually passed in parameters, so now we have a parameters tab where it includes some information about the parameters. Now, let's take a look at one other feature of Universal Automation in terms of host feedback. And what we're going to do is actually use readhost to prompt the user for additional feedback in a script. So I'm going to create a feedback script, and within my script I'm going to use readhost to ask the script or the user who is running the script for some additional feedback. So what should we do today? And then I will save that script. And now when we run the script, you're going to see that it doesn't prompt for anything when we first start up because there are no parameters specified. But when I do click Run, it will eventually run the readhost commandlet, and that will switch the job into waiting on feedback state. And you'll see that state in both the jobs view here as well as the scripts view, or the job view here. And in the top right corner of the job view, you'll see that we have a respond to feedback button. So if I click that, it'll say, what should we do today? And then from here, I can say, get some coffee. And then since this readhost isn't assigned to a variable or anything like that, it's just going to output to the console. And you'll see that get some coffee kind of shows up in the console as well as the pipeline output because it was passed in as a string. So that is another way to kind of take input from your users automatically inside PowerShell Universal. So if your scripts require decisions to be made or something like that while the script is running, you could have this waiting on feedback functionality integrated to enable your users to actually add additional feedback during script execution. Alright, so now I want to talk a little bit about schedules. So we've looked at some of the basics of the PowerShell host and taking in input and output and feedback, but one really nice feature of Universal Automation is the ability to schedule scripts. So there are two places to actually schedule a script. One is on the actual schedules page here in the top right. We have a new schedule button that will open up this schedule modal. The other place you can schedule a script is over on the script page where we actually have a schedule button. What I'm actually going to do though is create a new script, and this is going to be my scheduled script. We're going to go to that script, and from there I'm just going to call invoke web request, and we're going to check our website to see if it's up and running. So I will save that, and we will run this script just to see that it works. So that's going to actually call invoke web request. It's going to go out and it's going to hit our home page and then validate whether or not we're getting a 200 back. So as you can see, here's the output of invoke web request, and you can see that in the pipeline output. And then let's go ahead and schedule the script. So if I click on my PS1 here, it'll take me over to my script. I can click the ellipses and click schedule. And we have a couple scheduling options. So on the simple tab, you have access to a drop-down that provides several different types of schedules. Every minute, every 5 minutes, every 30 minutes, every 8 hours. And you can just select one of those and hit schedule, and it will create a new schedule for you here. So just as with other configuration options within Universal, you'll see that schedules are also stored as PS1 files. We have a new PSU schedule, and it defines the cron schedule that was used to create that simple schedule, as well as the script that we're scheduling and the time zone that we should run this in. Finally, we click Schedule on this tab. We also have some options for additional types of schedules. As you saw, we actually store pretty much all the schedules, simple or cron, as a cron schedule, but you can define crons yourself. So if you have a cron expression that you want to run your particular script as, you can do that here. And finally, we have one-time schedules that allow you to run a schedule job at a future date. So you can select the date and you can select the time, and then it will run that job at that future time. Additionally, all schedules have the ability to specify a alternate PowerShell version or a different account to run that as that scheduled job as. The final section here is the variables section. So variables allow you to define variables that are available to all scripts. So if I wanted to define a URL variable instead of using a hard-coded URL inside my script, I could just say name and value, and now the URL variable will be available in all of my scripts. Additionally, this is stored in the variables.ps1 file in our repository. And if we go over to our script and we edit our scheduled script, so let's actually change this over to use a URL instead of a string. We're going to run this, and we should have the same result as before, because now we're just expanding a variable that was available from the variables tab inside of the Universal Dashboard Automation section. So you can see it still works, and we still get Iron Man software returned. Alright, so the other type of variable that we have available to us are secrets. So secrets can be created in the add variable modal here on the secrets tab, and secrets are not actually stored themselves inside UA. They are stored as references to secrets that are stored in the Microsoft Windows or Microsoft PowerShell secret management module. So the secret management module actually takes advantage of Credential Manager to store secrets inside there. And what we do when we actually create a new secret within UA is that we store those using that particular module and the built-in vault. So one limitation of the current version of the secret management module is that it does not work on Linux, so this only works on Windows right now, but it looks like the next major version of the secret management module will be cross-platform. So if we click import secret up here, you can see I already have a secret defined. It's a PS credential. I've created that. It's for one of my IIS account users, and if I click that and then click OK, I now have a PS credential object that's available to me in both my scripts and as well as my schedules and jobs. So if I wanted to use the IIS variable to either pass the credential to some other command that I'm calling, or use a different type of secret like an app token or something like that for a separate service, I could do that using secret management. Now that I have a secret set up, I can also do things like when I create a new schedule, specify the alternate credentials to run this schedule as well as when I run scripts, I also now have the option to use this run as IIS to invoke the script as a different user. So this was an overview of using Universal Automation inside PowerShell Universal. Now that we looked at Universal Automation, let's take a look at how Universal Dashboard integrates with PowerShell Universal. So in the Dashboards tab, you're actually going to have some other options now. The first one is the Dashboards page, which will show you the dashboards that you have added. PowerShell Universal actually supports running multiple dashboards on different URLs so that you can have authenticated and unauthenticated dashboards, as well as dashboards that use different dashboard frameworks. A dashboard framework is an implementation of the commandlets and the client-side JavaScript that Universal Dashboard is built on. So as you can see, we have two dashboards that come included with PowerShell Universal. The first is currently the beta version of Universal Dashboard 2.9.1. So if you are using Universal Dashboard, the PowerShell module from the PowerShell gallery, this particular framework will work with your dashboards. So it uses all the same commandlets and the same JavaScript front end, so you should be able to port your existing dashboards over from the PowerShell module to use PowerShell Universal. We have a migration doc. There are some things that you don't need to do when you are using PowerShell Universal. We're trying to simplify Universal Dashboard a bit so that it's a little bit easier for people to get started and maintain their dashboards. Additionally, we have Universal Dashboard 3.0.0 Beta 5. This is the new version of Universal Dashboard built on new React controls that are updated. It uses new commandlets. So we also have a migration doc from 2.9 to 3.0, but that will take a little more work on your part because a lot of the controls have different names or do different things. So that's just the two frameworks you can choose from. Additionally, we have a components page. There are two components, or two component sets, I guess, that are come packaged with PowerShell Universal. First is the Universal Dashboard.charts module. This includes the Nevo charts as well as the Sparkline charts. Additionally, we have the Universal Dashboard map control, so you can actually use full-fledged maps inside your dashboards. So let's go ahead and actually create a new dashboard inside Universal. When we click Add Dashboard, it's going to ask for our name. In this case, I'm just going to name it Dashboard, and then a base URL. This is the URL that I'm going to visit to actually look at this dashboard. So you can specify a root URL such as this. By default, if there is no dashboard specified at the root, you're just going to end up on the admin console page. But if you have a root dashboard, it's actually going to go to the dashboard directly when you visit your bare URL. But in this case, I'm just going to specify dashboard. Then I'm going to use the Universal Dashboard 3.0.0 Beta 5 framework and PowerShell version 7.0.2. So when I click OK on that, it's going to go ahead and add a new dashboard. And you'll notice some information on this dashboard page is kind of interesting. On the left-hand side, we have a status for our dashboard. Dashboards can be stopped and started independent of the web server, so you don't actually have to bring the web server down and up to start and stop your dashboards. Additionally, you'll notice that we have a process here, so we're running in PWSH and the process ID is included in parentheses there. The reason that we run this in its isolated PowerShell process is that lots of PowerShell modules get brought into Universal Dashboard, and one of the problems with the Universal Dashboard 2.9 module is that a lot of modules conflict with Universal Dashboard itself. So now we've isolated Universal Dashboard, the actual logic for it, into its own process that shouldn't conflict with your PowerShell modules. You should be able to load up PowerShell or PowerCLI or the Azure AD module and that kind of thing directly inside your dashboard without many problems. If I click View here, it's going to take me over to my dashboard, and this dashboard is just our sample dashboard that you get when you create or you click Add Dashboard. That's using PowerShell Universal Dashboard v3. So you can see there's just a button here and then a Hello World string. Some cool stuff that PowerShell Universal brings is it brings a lot of the functionality that you would get from the enterprise version of Universal Dashboard, with some additional features. So first of all, we have the a code view that allows you to look at and edit your dashboard script directly inside the browser. So I can add some more exclamation points, that kind of thing, and it's going to go out and update my dashboard, restart it for me, and if I refresh that page, we should have some additional exclamation points inside our dashboard. So it allows you to kind of quickly iterate on the development of your dashboard by allowing you to just kind of edit the script and then refresh, kind of like the auto reload functionality of Universal Dashboard. Next, there's things such as logging built in, so you can easily look at the log that's generated when starting up your dashboard. We have some information about the modules that are loaded, the commands that we are loading into the Universal Dashboard run spaces, and then any errors that show up will show up kind of at the bottom here, and you'll be able to kind of troubleshoot those errors directly kind of from this log page. Another way to help diagnose errors with Universal Dashboard is historically been the admin terminal. And the admin terminal is still a part of PowerShell Universal. So you'll be able to connect to your Universal Dashboard run spaces via this console right here and execute commands inside those run spaces as if you were a user account accessing Universal Dashboard. And also, similar to Universal Dashboard Enterprise, we have session information. So we have this would list all the sessions that are currently active. I just have the one. When they were last active, how many endpoints have been generated based on that session, and then the username of the user that logged in if you're using authenticated dashboards. Additionally, we have endpoint information. If you have controls on your dashboard, you will you could add an ID here and then look at the average execution time to determine whether or not a particular endpoint is slow or control is slow to load. So that is kind of an overview of what's possible in Universal Dashboard inside PowerShell Universal. I'm not going to get into the details of building dashboards inside PowerShell Universal. There are some other videos out there. You should be able to use the same or similar techniques to build your dashboard. We're going to actually release a video in the future here for building dashboards with PowerShell Universal Dashboard v3 once we release the final version of that. So stay tuned because that'll have a bunch of cool information about all the new features of PowerShell Universal Dashboard v3. So now that we've looked at dashboards, I want to talk a little bit more about settings. Now that we've talked about all the different features of the PowerShell Universal platform, I want to talk about some of the configuration settings that you can set up for the platform in general. Some of the things that kind of go across all the different components are things like security and authentication, as well as various other settings including identities and Git synchronization. So first of all, on the General tab here, you're going to find information about where this particular instance of Universal is storing its repository information as well as its database. You can set the concurrent job limit. We'll only run that many jobs for the server at once, as well as changing the log level or hiding different aspects of Universal if you are not using those particular parts of it. PowerShell versions are kind of located automatically the first time you start up Universal, but in this case you could actually add your own version if you have a path that we did not locate, and then it will add that to a configuration file that you can then check into Git. And finally, if you have Git on, you're going to see your Git synchronizations down here. This will include information such as the commit ID, the number of changes, and kind of when this Git synchronization ran. So to configure some of these settings, not everything is actually configured through the UI. There are some settings that you want to configure in the app settings.json file. By default, you're going to have pretty much a template or the default settings for Universal in the app settings.json inside program files, x86 Universal app settings.json if you've installed via the MSI. This includes information about like where we are storing the repository data, where the database is, as well as where logs are stored, and where we store the Universal Dashboard assets such as the frameworks and components. Additionally, you have access to things like the authentication settings. For example, you can set things like whether or not to enable Windows authentication. You can set your WS Federation settings, so you can integrate with that for authentication and authorization, as well as OpenID Connect if you're using Azure AD or something like that. And if you are configuring for Git, this is where you'll also set your Git settings. So you'll put your Git remote in there. You want to include the .git at the end. We kind of actually recommend, even though we have username and password here, we're going to update our docs and potentially the app settings JSON to recommend the use of personal access tokens if you are using a service such as GitHub, because then you could generate that and include that into the Git password setting here, and then it's a little more secure than you actually putting in your username and password. One thing to note with the app settings.json is that this file, you don't want to actually edit it inside the program files x86 necessarily, because it will be overwritten when you upgrade. So we recommend that you put it in the program data / PowerShell Universal folder. There's documentation on how to do that on our docs page. Additionally, you can also set all of these values as environment variables or command line parameters to the universal server.exe. And there is also documentation on how to do that on our documentation page. So one thing to note about all the configuration files inside Universal is that you can actually edit these files directly inside of your editor of choice, and Universal will actually pick up the changes automatically, and then that will be reflected inside of Universal itself after it picks up those changes. So that is nice if you want to actually, instead of using the UI itself, you can come in and just use a text editor to update these files. And for example, I just updated that API, and you'll see that that API was actually updated inside Universal automatically. I didn't have to reload anything or anything like that. So if you edit any of the files, including your dashboard or your multiple dashboard pages, that kind of thing, Universal is actually watching this repository file and then will reconfigure itself based on the changes that you make there. You can turn this off. It's available on the settings object, or in the future what we're going to do is scope it a little bit so you can kind of determine or decide what you want to auto reload based on changes. If you have git sync on, it will also auto reload settings every time it does a git synchronization and that kind of thing. One last thing I want to talk about, we touched on authentication a little bit, but I want to just talk a little bit about the security settings that we have available in Universal. First of all, if you have a default version of Universal, you've noticed that I've logged in with admin and no password. But what we can do is we can actually modify that forms authentication code by clicking this security setting here. And going to the forms authentication settings page, and it's just a PowerShell script. You're going to receive a PS credential object from the forms authentication, and then from there you can validate that however you see fit. In this case, we're just checking to see that your username is admin. We're creating this authentication result, and then we're going to return whether or not it was successful, and then the username that was provided. So this is one way of doing very basic authentication. You could potentially integrate with Active Directory here or whatever authentication method you want, but it might be more customizable if you actually integrate with something like Windows Auth via IIS or OpenID Connect, that kind of thing. Additionally, what you can do is configure the roles that are available inside Universal. So currently we only support 3 roles, and they're primarily used for API authorization, automation support, and access to various things in the Universal admin console. So, for example, administrators can edit all the settings and that kind of thing. Operators can only add scripts and execute scripts, that kind of stuff. And readers have read-only access to both the API and the admin console. In the future, we'll be adding additional role capabilities so that you'll be able to add your own roles and then assign those roles however you see fit. And there's kind of 2 ways that you can assign roles to your users logging in. First of all, you can pretty much assign roles manually and specifically to a user. So our default admin user has a policy-defined role right now, but if I wanted to, I could specify a manually defined specific role for this identity. So then anytime they log in, they have that role. But when you specify policy defined for an identity, what you're actually going to see here is that we actually have these policy actions on the right hand side. So we can edit the policy for admin roles. And inside this policy, you're actually going to receive a user object. Then that you can evaluate whether or not they are part of the administrator role for whatever criteria you see fit using a PowerShell script. So this policy will run on login, and the user object is actually a complex object that contains all the claims policies that your user is granted. So if you're logging in through Windows authentication, it's going to include things like group membership and that kind of information. And then you can evaluate whether or not that user fits the administrative role. And if they do, you can return true or false from this claims policy, and that user will then have that role depending on what you return. And just like every other configuration option inside Universal, authentication and the roles are all defined inside PowerShell scripts, so you can go ahead and either edit that in Git or in the UI if you want to. So that is kind of a whirlwind tour of PowerShell Universal 1.2. I definitely suggest that you head over to our website and download it. It's free to download. You can run up to 25 jobs a day. You can run your dashboards as long as they're authenticated, and you can run as many APIs as you want as long as they're not authenticated without a license. So there's lots of stuff you can do. It's very similar to what you could do in PowerShell Universal Dashboard Community Edition. So definitely go ahead, grab whatever flavor of the installer that you'd like, and get up and running with PowerShell Universal 1.2.